the first example. Whenever you have a number multiplying the function affecting the output, and it's a number greater than 1, what we have is a vertical stretch of that function by that factor that you are using to multiply. Okay, so what I want you to pay attention in this video about is we're looking at what happens to the coordinates of the points, the coordinate of the points on the parent function. What happened to the coordinates? So let's look at this. Whenever 2 is multiplying the function, let's see what happens. All right, so the first point on the parent, I shows 1. This parent is a dashed one. Okay, this is a parent, 2 to the power of x, and then so that's the dash one. So this is 1 comma 2 there. You can see on the child function, the new function, that this 1 comma 2 has become 1 comma 4, 1 comma 4. All right, I pick another point, 2 comma 4 on the parent has become 2 comma 8, 2 comma 8. So pay attention to what's going on here. You can see that the input is not changed. Is the same number, set of number. Input is the same set of numbers, but the output has changed. The output has changed by how much? Well, you can see that from here, 2 has become 4 by multiplication by 2. 4 has become 8 by multiplication by 2. So we see that the effect of vertical stretch is to multiply the y coordinate by 2. Okay, let's look at vertical compression. Now we can see the same thing. The input is not changing, but the output is changing. And you can see the factor is by 1/4. See, is by 1/4. All right. So 2 becomes 1/2 by 1/4. 4 becomes 1 by 1/4 when you multiply by 1/4. All right. That's the one that's a lot difficult for a student to grasp. Is just to be able to see the factor, how it plays out on the coordinates. Okay, let's go to another one. Here's another one. Okay, this one is actually more difficult to grasp because it's counterintuitive. Okay, let's see what happens but when we say horizontal stretch. Horizontal stretch. Let's go back to the previous one. This one was vertical stretch by 2, but when you go to horizontal, what's going on here? I was thinking this one, you'll be thinking in your mind and say 1/2 by a factor of 2. How is that possible by a factor of 2? Okay, let's first of all look at the points and then we'll come back to that. Okay, let's start with 1 comma 2. 1 comma 2, what does it become? It becomes 2 comma 2, 2 comma 2. Let's look at the other one. 2 comma 4, this place stretch sideways. When you stretch it sideways, it becomes 4 comma 4, 4 comma 4. When you stretch it sideways, you will notice immediately that the y does not change. The y does not change because the input is getting affected. X is getting affected, so the output does not change. So y is staying the same, but how do you go from 1 to 2? You multiply by 2. How do you go from 2 to 4? You also multiply by 2. So it's a stretch by a factor of 2. However, when you write a factor that goes with the x coordinate, the x value, it's actually a half of it. So horizontal stretch by a factor of 2 shows up as 1/2 x in the exponent. All right, the reverse is true on the other side. This will be a compression by 1/3. See? Now, I told you in class before, something that allows you to remember that x always lies. Your x is always lying. All right? So that's some funny thing there, but it helps students to get it. Your x is always lying to the other person. So So which is, if it is horizontal stuff, it's always lying. All right. Okay, so it's like a factor of 3 here, but actually when you look at the point, let's consider the point. The parent is 1,2. Let's use 2,4 this time. 2,4 is obvious to see. The parent is 2,4, is dragged now to a new location at this is like 2/3. Okay, it's 2/3. So it's 2/3, comma 4. Okay, whereas the 3,8 is now dragged to 1,8. It's now 1,8. So we can see there that the output value stays the same, but the input has been divided by 3. Oh, let's use the other one. Sorry about that. This has been divided by 3. 2 divided by 3 is 2/3, and then 3 divided by 3 is 1. Okay, so we are dividing or multiplying by 1/3. I spend a long time on this because the horizontal stuff could be confusing, but that's just the way it is. What if I have vertical shift? This one is pretty obvious. It's not too hard. It's just adding to the y coordinate. So 1,2 here becomes, the x stays the same. This one becomes plus 2 is 4. You can see there. And then s stays the same because we are adding to the output 2. And then add 3 to 4 becomes, we're by 2. Add 2 to 4 becomes 6. It's right there. It goes to 6. This is the parent. This is the child. This is the parent. This is the child. So we're just adding to the output. We're adding 2 to the output. All right, let's do the other one. We're subtracting here from the output. We're subtracting. So if I give you 1, 1 for the x stay the same because we are not touching the input. And then 5, we're subtracting from 2, we're subtracting 5. It's going to go to negative, so it's going to be negative 3, okay? So it's to negative 3 when you subtract 5. This one is 2 here. It stays the same because the x is not affected. And the 4 is you're subtracting 5 from 4, it goes to negative 1. So we can confirm that on the graph. You see, 1, this 2 here becomes negative 3. You can see that. And this 4 here becomes negative 1 when you subtract 5 from it. So it becomes negative 1. So here, whenever you see a function like this, it's just telling you to add 2 to all the y values, or the y coordinate. Here I say subtract 5 from y coordinates. Don't touch the x coordinates. That's what it's saying. Okay, let's move on. By now you're getting a hang of it. I hope so. Here, what's affected is the input. So the output is going to stay the same. So I can actually write this like it's going to be something, comma 2. It's going to be something, comma 4. I'm writing ahead of time because the y value is not getting changed. Okay, like I said, the x value is always lying. So it's doing the opposite of what we expect it to do. So when you see x minus 3, we're actually adding 3. We're going to add 3 to 1. 3 plus 1 is 4. And then 3 plus 2 is 5. We can test it. Let's see. The x value from the parent to the child is becoming 4, 2, and then 5, 4, which is true. So the input stays, the output stays the same this time, but the input is getting affected. It's a lot. Reflection. If you have a reflection across the y-axis, so you can see the parent has been flipped the other way. It's been flipped the other way. So you can see that when you flip across the y-axis, only the x values are changing. The y value stays the same. So that's why 0,1 here, 0,1 here stays the same, 0,1. But 1,2 becomes negative 1,2. So -1, the x value is just flipped. It becomes the opposite. But when you reflect across the y-axis, see, the y values are going to stay the same. And the x value is going to be flipped. 0, 1 is, since the y value is the one that's changing, the x value stays the same. So 0, 1 becomes 0, -1. You can see that. And then 1, 2 becomes, because the x value in 1, 2 becomes, the x value is going to stay the same, 1, -2. So you can see what we do here is we negate the x coordinate. We negate it. We put a negative on it. Here we negate the y coordinate. You might need to stop the video and rewind it and, pause, take note, because it's kind of confusing a little bit. Sometimes you have to play around with it. All right, let's apply this now to a function. All right, here is one application here when you have a bunch of them happening here. So I see that there is a compression here. So there's a vertical compression by 1/4. There's also a vertical translation by 4. The x is not affected in this case at all. So there's a vertical translation up by 4. Okay, let's apply it to these points now, okay? Vertical compression by 1/4 means the y values are going to be divided by 4. All right, let's take 3 points here. So let's use, I don't like the 0, 1. Let's change it to, let's just use the 1, 2 first. 1, 2. So remember, this is an output change. So we're going to only look at the y values. So this one is going to become the x stays the same. The 2 is going to be divided by 4. If you divide 2 by 4, you're going to have 1/2. So it's 1/2. All right. The x is going to stay the same. I'm still applying, first of all, I'm applying this now, the compression. Now, the 4 is going to be divided by 4. 4 divided by 4 is 1. So the new y values here is 1. But we're not done. We've only applied that compression. We need to apply the shift, vertical shift up. So this new one also translates now. If I shift, the x value is going to stay the same. 1/2 is going to be shifted up by 4. It goes to 4 and 1/2. 4 and 1/2. And then the 1 is going to be shifted up by 4. So it becomes 2. 1 plus 4 is 5. So 5. Okay, let's just do one more point to make it clearer. All right, let's say I do 3,8. 3,8. The first thing is the x stays the same. And then you divide 8 by 4 is 2. After that, you will add 4 to the new value, becomes 3,12. Okay. All right. So let's plot this point to see where the new values, where the new graph, how it's going to look. To make it easier for us, you see that this 4 here is the asymptote, or is the vertical asymptote. So I'm going to draw it. All right, I will raise this new position. Then we write the new position at 1, 4.5, and then 2,5. Okay, and then 3,12. Okay, and now I can erase this, and then let's draw the new asymptote. The new asymptote is going to be at 4, y equals 4, and then now we're going to write plot the new location of each point. 1 and 4.5 is going to be over here. And then 2 and 5 will be over here. And then 3 and 12 will be somewhere over there. 3 and 12 will be somewhere over there. So the new graph is going to look something like this. Okay. Something like that. All right, so we've applied 2 transformations to that to get the new graph. All right, last example here is going to be given, you're going to be given a graph, but only you have to decide which of these equation function goes with the graph. Okay, so the first thing you can notice is that there's a shift in the asymptote used to be y equals 0, but now the new asymptote is y equals -4. And that's the last, that's just the number, the last number, the second term there. So straight away we can just eliminate this because the asymptote is not a -4. And then actually we can eliminate this also. But let's just prove that this is correct. So if you look at it's saying there's a reflection as well. See, it was a reflection across the y-axis. So the x coordinates are getting changed to negative. So that's why this is a correct one. So this is really fun to do. The exercise you're going to do today is going to ask you to do a bunch of this, where you have to use what you know about transformation to select which equation goes with them. I know the video is long. It's because I want to make sure you know what's happening to the points, not just the graph, but the points on the graph. Well, I hope this is a little bit helpful to you, and I will see you during the next lesson.